This podcast is sponsored by Oracle. Experience easy, rapid, and agile deployment of any Java EE application using Oracle Java Cloud Service. Gain full control and flexibility of your applications in public cloud. Learn more by visiting cloud.oracle.com.
Welcome to the InfoQ podcast, a software engineering podcast brought to you by the people behind InfoQ.com, a software engineering news site to help progressive software development teams adopt new technologies. InfoQ are also the people behind the international software conference, QCon. This is Robert Bluman. I am here at QCon San Francisco 2016 with Preslav. Preslav is a software engineer at Dropbox for the last 3 years, where he contributed to various aspects of Dropbox's infrastructure, including traffic, performance, and storage. Preslav, welcome to the podcast.
Thank you, glad to be here.
Would you like to tell the community any more about yourself?
So I grew up and graduated in Bulgaria, in East Europe, so forgive my accent. I got into programming through programming competitions, which are much more popular in Europe than in the United States. First, I was interested in building computer games, computer graphics, did some internships at NVIDIA game company called Masthead. Then jumped to the startup world, worked on a travel technology startup called Everbread for 3 years. Learned how amazing and complicated the flight industry is, and found there interesting problems everywhere. So I then spent a little time in VMware, and I'm working on Dropbox. And as you said, I'm working on various aspects of the infrastructure, for example, traffic, where I built the first version of Dropbox Edge Network, performance, where I was instrumenting our code so it's faster, which is the obvious thing, and currently working on this thing that became famous, our in-house built box storage system called Magic Pocket.
Great. Today I want to talk about Dropbox's migration off the cloud. Wired magazine did an article on this, which we'll put in the show notes, and there were a lot of interesting ideas that came out of that article. I'd like your perspective on. Wired magazine said today more companies are moving off the cloud than on. I want to start with, why did everybody move onto the cloud?
I'm not sure I agree with that. I think more companies are moving on the cloud than off, so
Okay.
we are kind of the exception rather than the rule. First, I want to clear one misconception, is that it's not that like Dropbox were running on Amazon completely and one way we decided to move off, right? We had, during all the time since Dropbox started, we used Amazon where it made sense. We used Amazon S3 as well as run other services that needed to work with files. During that entire time, all the metadata was stored in our own data centers. So through the years, we were very experienced in building multiple data centers, how to operate them, capacity planning, and so on. So it was, when we made this decision, wasn't a blind jump somewhere. Whether we can build a data center was not a question. And Amazon has always been a great partner for us. But we just have the policy of use third parties where it makes sense.
So talk about what parts of Dropbox did you decide to move off the cloud, and what was the thinking behind that?
Yeah, so as I said, majority of actually all the metadata was always living outside of Amazon infrastructure. I'm not expert at why those decisions were made early on, but like some of the things I know was back at the time there was no good database solution for persistent databases and so on. S3 was an amazing service, but not everyone was there, so we needed to pioneer it. So we used S3, which was super solid and great service, which made a lot of sense. For the other stuff, like when Amazon Amazon Web Services became what is now, we were already very proficient at running our own databases, and it didn't make sense to move them back. So by the time we were ready to tackle the box storage problem and build a service similar to S3 ourselves, it made sense to move completely off Amazon.
The decision, was it primarily driven by the economics and cost factors, or technical, or features, or what?
It's a combination of all those, right? So it's strategic decision, but also if it wasn't cheaper and we would degrade our product, we wouldn't do it. So like one thing that came from the article is like no one runs cloud storage as a non-profit, or like just to make things cheaper, right? And you have massive scale, we can actually make it cheaper for us. Also, we know our use cases much better. We know the average block size we store, we can divide it on the upper layer and so on. So we could optimize for our use cases and be faster.
Organizations that are just starting out, the main cost factors will be speed of development, cost of programming. It sounds like there's a crossover point where by building customized hardware that's optimized for your use case, you're able to save money. Is that accurate?
That's definitely true, but like again, it requires this economy of scale, right? And another thing that's important is that this needs to be part of your core business, right? You need to care about this problem and understand your workflows. So then you can build something better than the generic managed solution. And the third thing, as I said, you need to have a great team, and we already know how to run our data centers. So yes, at one point it makes sense to run to your own hard drive storage, and then from there you can do many things. We experiment with new hard drives, SMR, Shingled Magnetic Recording, that are much denser than normal PMR drives. The idea is that the read head can be smaller than the write head. So those hard disks are denser to the expense you can only write sequentially, and writes are slightly more slower. We could change our software to accommodate that and buy those cheaper drives and get denser. We also built our own chassis to fit as many hard drives in a single box as possible, which makes this as dense as possible. And the next problem we're actually hitting is you can imagine those like racks with 102 disks per machine. We can stack eight on them on a single rack, but they're so heavy the floor cannot hold more. So we need to figure out how to reinforce our floor and so on.
So what I'm hearing is if you control all layers of the stack, and by that it means even the physical build of the space where the devices sit, that you can optimize the entire system by making changes at one layer that are supported at other layers. So
that's definitely true. We modified our software to work with SMR. We modified our chassis to work, and we have like very good hardware people who specialize in hard drives. We have people designing data centers. We have amazing software team who knows how to build distributed system, and it's like very tight cooperation with all those. And also there's things like capacity planning, how many racks you can ship to store your data. You shouldn't run out of space and so on.
The industry, it's pretty good at offering a standard server which is built for the average needs of the typical user. What kind of supply chain and issues were there in getting non-standard builds that were optimized for your use case?
I'm not very familiar with those aspects. We definitely we need to, when you work with something new, you need to work with multiple providers so you can not get screwed by one of them going out of business and so on. So you need to catch your vendors and so on. Other than that, I'm not familiar about the contract details and so on.
So you talked about the hard drive technology and ratio of read writes and the order of accessing. Talk about the access patterns of Dropbox's use case that impacted decisions about the storage technology and how.
So one thing is we know like the distribution of how hot different blocks are and how often they get accessed. One pattern is that when you store blocks, they almost immediately get accessed because we have all those desktop clients that download them immediately. And then you can see like in 1 day or so they get accessed again for various reasons, and then over time they become colder and colder. So that's one thing. And then other things is we know the average size of our blocks. So because to make things more reliable, we split, for example, 1 gigabyte file in smaller blocks, for example, 4 megabytes. And this means the average block we store on our system averages to around 1.6, because maximum is 4, minimum is 0, and average is around 1.6 megabytes. So this also allows us to tune how to store our metadata and how to store our block data. And then you mentioned SMR. This is fairly new technology. It's like you can use it for backups and things like that, but we wanted to use it as our primary storage. For this, we, for example, added an SSD cache. So all writes go to the SSD and then asynchronously get forced to the SMR disk. And some background operations that we can allow to be slightly slower go directly for SMR to SMR disks and so on.
And what type of file system did you use?
We have our own file system. It's backed up by MySQL databases, and you can think of its file system as like a file journal. So we say this is the name of the file, this is the path, it's within a given namespace, this is the list of blocks this file contains from, this is the modified date, and so on. And it's an append-only log. So when we modify the file, we append a new line and mark the previous line as deleted. This allows you to go to at any point of time if you still have the data on our storage system and see and recover files. For example, this is how we have 30-day recovery for any files. We have some of our users can buy like 1 year version history, and also for Dropbox for Business, we offer unlimited version history.
Is this file system developed by Dropbox engineers?
Yeah, I wouldn't call it file system because it's not so multi-purpose, right? It's more of a one word file journal, and then we add and edit files in it.
Did the project have specific design goals, or broadly speaking, goals that you were trying to achieve?
It had very clear design goals, right? So Dropbox at that point was not a startup. So we had, I don't remember the exact number of users that we have, but right now we have 500 million users, and we needed to make the migration while everything is running. So no user should even notice the difference, right? We cannot go down, we cannot be slow, we cannot shut this user and say re-upload your files, right? We need to handle this on the side. So the requirements were be as reliable or more reliable than Amazon, be as fast or faster, and be able to handle this massive scale. It wasn't a question of whether after we built the system, whether one day we'll be storing 500 petabytes of user data. We knew that we'll be doing it. So those were pretty clear requirements.
Did the project achieve most of its design goals?
I think it's absolute success, right? We managed to move off Amazon. No one noticed. We give this comparison on the article where it's on Wired article where we say it's like changing the engine of an airplane while it's playing and while it's flying. I would say it's slightly easier because software is hopefully easier than hardware, but there were like a lot of comparisons. So it was a hard problem, and given that no one understood about it until we announced it to everyone, I'd say that was a huge success.
I'm going to guess you didn't just move all the files over and flip a switch from A to B. What kind of migration strategy did you employ?
Yeah, so you cannot migrate 500 petabytes overnight, right? Like nothing supports it. It's the network bond between us and Amazon and everything. We needed to negotiate as large pipe as possible so we can ship the data, and even with that, it took months, right? So we needed to figure out how to solve this problem. This was another requirement, right? Don't stop running. We built another service, which is bulk routing service that was telling us where data was located for each user.
Did you say bulk routing service?
Bulk routing service, or file routing service.
Okay.
So we know where the data for each folder or each user is located. And then this way we could leave at both places at the same time. Even today we have this ability to switch between us and Amazon. And then you can smoothly transition. And for a while we had this, we run Magic Pocket in a dark launch strategy, meaning that we had the data in both places. We read it only for Magic Pocket, but if disaster happened, we could just flip the switch and get back to Amazon continuously. And the day of the launch was the first day we actually deleted the first byte off of Amazon, and there's no going back, right? You have the data only in one place, and it's in your own data center. Building such service like routing service, made a lot of sense in the long term because we built European storage, and then you need to know is that user data in the US or in Europe and so on.
Was there anything unexpected that occurred during the migration?
There has been a lot of unexpected things. Like as a software engineer, you never think like you worry about how many racks fit in a loading dock and how many racks you can shift at a given time. And so, of course, as we scale the system, all kinds of things break, and like we fix them. So yeah, there were a lot of small unexpected things, but like this is just part of life. I wouldn't say there was something that was a deal breaker and made us give up.
According to Wired magazine, Dropbox was mostly written in Go at one point, but as part of this migration, you switched to Rust. Is that correct?
It's not entirely. Okay. So Python. So we use 3 languages in our backend infrastructure. Python is like the front ends that have most of the business logic, right? And then Go is better suited for heavy infrastructure services. So many of our services are written in Go, and Go is still the primary language for our infrastructure. For some places where it makes sense, we use Rust.
Okay. So what aspects of Go were not meeting your needs in those areas where you switched?
Yeah, so one area is our own disk storage service. We call it OSD. So this is one of the most critical components in Magic Pocket because it's handling the state. It's actually writing to drives and has API of how to work and store blocks. The reason why Go is not great fit is because of garbage collection. This service is very, very memory intensive, and over time we're getting denser and denser by indexing more and more data on a single storage node. We buy bigger disks, we buy SMR disks, and so on. So to make this work and to be able to fastly get any block out of the system, we needed better control over memory, which Rust provided. Other areas where we experiment with Rust is our desktop client, because this is actually running on our desktop client machines, and then very fine control over resources is very important. So I'd say like Rust is important for like very constrained environments, or it's more of a system language, while Go is like easier to use and it's more a distributed system language. You can do the majority of things with Go, but there's no one tool fits all.
So looking at the economics of it, one of the main things people benefit from the cloud is they're able to consume more capacity on demand and then shed capacity when they don't need it. How do you go about capacity planning, and do you have to maintain a lot of idle capacity for your worst case?
Yeah, so that's one of the things when you are off the cloud, you need to be, your stuff and do capacity planning. We have amazing capacity planning team that works with different product teams, and we estimate how much capacity we'll need over the next year and so on. So I wouldn't say we keep too much of a buffer. You also always need some buffer for something unexpected, but we're pretty good at estimating our capacity. And another thing is we haven't declared war on the cloud or anything, right? We moved off Amazon because it made sense for us. Like if at any point it makes sense to move some services back, we'll do it. And as I said, storage is like our core business. For things like DNS, email, we still leverage cloud providers. We don't want to build everything ourselves, just the things that make sense.
How has this impacted your deployment pipeline?
Deployment pipeline, I wouldn't say, so one thing that impacted was we needed, when you build a storage service, what you're the most afraid of? You're afraid of losing data, right? So what we do is we replicate each block across different storage regions located in different data centers and different geographical locations, right? So this helps with natural disaster. But if you have the data in both places and you have the same bug on both, it doesn't help. So one thing we did is like we made this decision to have very simple API between our storage zones. So although they were storing the same set of data, we could have a stage release process and release one storage zone at a time. So this helped us catch any early bugs early on the process. And another thing is even for latent bugs that don't show up for a while and you don't discover, it's very unlikely they appear at both places at the same time at the same set of data. So this is how we defend ourselves versus ourselves. And other things we do is we invest very heavily in verification and automation. Pretty much when you need to push from one place to another, how do you know your system is ready, right? You cannot just look at graphs and see, oh, I lost 5 blocks, so maybe it's okay. At any point of time, we want to guarantee our system is 100% correct, that everything is there and so on. And this is where verification comes in. So we have verifications at different layers of the stack. We have verification that scans every byte on disk and make sure it matches the checksums it should in the index. We have verification where we go to each box and ask, do you have the box, the hashes, the block keys I believe you should have. We have black box testing where we go and see, okay, I put this block 2 days ago, do you still have it? What about 2 weeks from now? So at any point of time, we first deploy to a stage zone that doesn't have, that it's not only copy of the data never. And after all verification work for a few weeks, then we push to the next storage zone and so on. So at any point of time, we can be 100% sure our system is correct and we can deploy.
And if layers of verification find incorrect data, does the system have the ability to recover?
Yeah, of course. So there are different types of incorrect data, right? So some things that happen every day is, for example, there's some error on some disk. And then the system is able, like the storage node just declares this disk failed, and then our system goes and replicates the data somewhere else from the other replicas we have. So things like this happen all the time. But there are some of the verifiers that they just show 0 all the time, and they should show 0 because, like, if you have something that you believe it's in your index but it's not on the actual file, on the actual storage node, this is a big problem. It's a bug somewhere. So this is where we need to jump in, investigate, and figure out what's going on and fix it. So for those unexpected bugs, there's no like some magic out to recovery, but at the end of the day, the graph should also be 0. Which also reminds me of another thing is, if you have a graph that always every single day shows 0, how do you know that graph is working in the first place? So this is where it's important to actually go and trigger errors and for example, go and manually corrupt something that shouldn't be corrupt and make sure that your verifier works.
So you have to do a full cycle testing of the verification.
Yes. So we verify the system that's correct for every piece of software. We ask ourselves, if there's a software bug in here, which system is going to have it, to catch it? And then we build a verifier, and then we need to go and test the verifier as well.
One of the things that drives people to use clouds like Amazon is API driven. Did you employ an open source on-premises cloud solution on your data centers to provide you with APIs to manage?
No, I'd say no. Like for many years, we have a lot of experience. We run our data centers from day one. So over time, we had like tooling for how to deploy, how to replace our databases, how to replace our hosts. So I wouldn't say we leverage too much of the some of the shelf ready stack open source solution out there.
No large project of this size goes exactly as planned. What were some things you learned in doing this that you didn't expect?
So I definitely learned much more about how data center works and how how capacity and shipping works. Because as a software engineer, you never think you need to learn so much, right? You write your code, you deploy it, it magically works somewhere. But when you build a storage system, you need to know what's a rack. You need to know there's a switch on top of the racks. You need to know that you can saturate that switch. You need to know that you have different clusters, different rooms. There are routers between them. You can saturate those routers, and all little things like that. We came to work much closer to our data center team and our hardware team, and you find things like switches have bugs. You find things like hard drives have bugs, and so on. Especially as you work with new technologies and so on. So no one is perfect.
And what happens when you find a bug in a component you don't own or didn't build?
So it depends on the stage, right? So in order to to buy hard drive, we have multiple vendors, and we replicate data across multiple vendors to minimize our exposure. And to buy like massive scale of anything, we just need to verify it, run it for a while, and so on. So we first buy a small portion, then we run it for a while, and so on. As well as like when like new technologies like SMRs are concerned, we work very closely to the hardware manufacturers. They send us the first versions. This is not what's going in production. Firmware is not final, so we test it, see whether it works. We expose some bugs in the firmware on the hardware. We get it back to them. So in those cases, you just work closely with the hardware, but you never commit to buying like mass quantities of hard drives when you know there might be bugs in them. And the other thing is vendor diversity. Software is hard, but hardware is still hard. So you need to hedge.
Preslav, this has been a great conversation. Thank you very much for talking to InfoQ. For InfoQ podcast, this is Robert Bluman from QCon San Francisco 2016.